Hello students. Today we will start our discussion on Introduction to Remote Sensing. All ITC students, one way or another, deal with geo-referenced data. They might be involved in the collection of data, processing of the data, analysis of the data, or actually using the data for decision making. In the end, data are acquired to yield information for management purposes, water management, land management, resource management, etc., etc. By data, we mean representations that can be operated upon by a computer. By information, we mean that data that has been interpreted by human beings. So, now we will discuss the methods used to collect geo-referenced or geospatial data. The need for spatial data is best illustrated by some examples. Suppose the first example we are taking, that is, an agronomist is interested in forecasting the overall agricultural production of a large area. This requires data on the area planted with different crops and data on biomass production to estimate the yield. Suppose the second point we want to discuss, an urban planner needs to identify areas in which dwellings have been built illegally. The different types of houses and their configurations needs to be determined. The information should be in a format that enables integration with other socioeconomic information. Point number 3. Suppose we are engineering, an engineer needs to determine the optimal configuration for siting of relay stations for a telecommunication company. The optimal configuration primarily depends on the form of the terrain and on the location of obstacles such as buildings. Last point, suppose a mining engineer is asked to explore an area and to provide a map of the surface mineralogy. In addition, he or she should start to give a first estimation of the effect of water pumping on the neighboring agricultural region. Last example we are taking, that is, a climatologist would like to understand the causes of the El phenomenon. For this, he or she would need data on any parameters including sea currents, sea surface temperature, sea level, meteorological parameters, energy interactions between the land and water surface, etc. criteria. In case, we have to note that all the above examples deal with spatial phenomenon. In fact, with spatio-temporal phenomenon, since time is an important dimension too. To satisfy the information requirements of the above mentioned examples, a wide variety of methods will be used. Conducting of interviews, land surveying, laboratory measurements of samples, interpretation of satellite images, measurements by individuals' sensors, using aerial photographs, running numerical methods, etc., etc. In our purpose, or for this case, it makes sense to distinguish between ground-based and remote sensing methods. Let's start with the ground-based remote sensing methods. So, ground-based and the remote sensing methods are two different terms we will discuss now. So, first we will start with the ground-based methods. Ground-based methods such as making field observations, taking in situation meaning measurements, and performing land surveying. Using group-based methods, these are the examples of the ground-based methods. Next, we want to discuss about the remote sensing methods. That is our main motto. So, remote sensing methods, which are based on the use of image data acquired by the sensor, such as aerial cameras, scanners, or radar. Taking a remote sensing approach means that information is derived from the image data, or which form a limited representation of the real world. Now, if we see, we will start to find out our task to find out the definitions, or what is the definition of the remote sensing method. So there are different definitions that is proposed regarding the remote sensing. So first one, we will try to emphasize our discussion on first example we are taking, that is the definition of remote sensing. Suppose remote sensing is the science of acquiring, processing, and interpreting images that record the interaction between the electromagnetic energy and matter. That is the first thing. Next definition, suppose we are taking, remote sensing is the science and art of obtaining information about an object, area, or phenomenon through the analysis of data acquired by a device that is not in contact with the object, area, or phenomenon under investigation. The second definition is also very important because that is a contactless information we are gathering using the remote sensing. Let's move to the third definition. What is the third definition? Suppose the third definition is remote sensing is the instrumentation, techniques and methods to observe the Earth's surface at a distance and to interpret the images or numerical values obtained in order to acquire meaningful information of particular objects on Earth. So common to the three definitions is that data on characteristics of the Earth's surface are acquired by a device that is not in contact with the objects being measured. So contactless measurements, contactless acquirement of the data, that are the main motto under the remote sensing. The result is usually stored as image data. The characteristics measured by a sensor are the electromagnetic energy reflected or emitted by the Earth's surface. This energy related to some specific parts of the electromagnetic spectrum, usually visible light, but it may also be infrared light or radio waves. There is a wide range of remote sensing sensors. Sensors linked to a certain platform are classified according to the distance from the Earth's surface, airborne and basically spaceborne sensors. Together, they contribute to aerospace basically surveying, which is the combined use of remote sensing and ground-based methods to collect information. That's all for this particular class. Next class, we will try to basically see the classification of the remote sensing. That is, we want to discuss about the active and the passive remote sensing in the next class. So